Okay, this is part 2 of the quiz review, polynomial division over chapter 2.3, and we're going to work on dividing. So the first problem says divide those two. I can't actually use synthetic division because there's a squared here. That is a binomial. There's a leading coefficient of 1, but because of that squared, I can't do it. So I have set up long division, and you might notice there's no x cubed term, so I put a 0x cubed in there just as a placeholder. I may or may not need it, but that would be set up like that. Okay, got to multiply to get x squared to change to x to the fourth, and that's x squared is my multiplier, and then I distribute. X squared times x squared is x to the fourth. X squared times 2 is 2x squared, and I'm going to put it in that spot. I don't want to forget to subtract the 2. x4 minus x4 is gone. 0x cubed minus 0x cubed, there's nothing there. 3x squared minus 2x squared is x squared plus 3x minus 2. I got to turn x squared into x squared. I need 1 to multiply by that binomial. So 1 times x squared is x squared. 1 times 2 is 2. Oops, just 2. And I'm going to subtract. And I get x squared minus x squared is gone. 3x minus no x is 3x. And negative 2 minus 2 here is negative 4. And there's no other multiplier I can multiply by to get that. So I'm done. The answer for the division is x squared plus 1 plus this remainder over that thing that did the dividing. So 3x minus 4 over x squared minus 2. Is x squared a factor of the polynomial? Definitely not, because of remainder. All right, now for the big problem. This is one like we did in class. Big time problem here. Gives me a big polynomial, gives me some factors, and wants me to do a lot of stuff. So here we go. It says x minus 2 and x plus 3 are factors of that big polynomial. It wants me to show that they are indeed factors. So what should happen is this should divide into this evenly, and this should divide into this evenly. These two binomials should divide into that, and because they're binomials, I can go ahead and use synthetic division. So I put a 2 out in front. If that's the factor, that's the 0. The 0 is what goes out in front. 3, 5, negative 17, negative 13, and 6. And I already know I'm going to get a 0 here because it says show that they are indeed factors. So if I don't get a 0, I did something wrong. 3, 6, add 11, multiply 22, add 5, multiply 10, add negative 3, multiply negative 6, add 0. That should have happened. Now you take the second factor and you put it into what's left over. You don't restart. That's gone. X plus 3 is the factor, negative 3 is the 0. And I'm going to do the same thing. I should get another 0. Drop the 3, negative 9, 2, negative 6, negative 1, positive 3, 0. Yes. Remainder, constant x, x squared. And I got zeros in both, and my resultant of the final thing was 3x squared plus 2x minus 1. That's not really the answer. The answer is the work here, showing that they're factors, but that's going to be important later, so I just wrote it down. Take the result of the division and find the remaining 2 linear factors. This is a factor. The other 2 linear factors is what I get if I factor it. So I'm going to try 3 and 1. I know it's got to be 1 and 1. I just got to get the signs right. I'll put the negative there. So I got negative 1, that's 3, that's 2. I got the middle term. I think I got it. 3x minus 1, x plus 1. Just going to FOIL it out in my head. 3x squared minus 1x plus 3x is 2x, and then negative 1 and 1 is 1. So I got it. I have the other two. These are both linear factors. Write the complete linear factorization. The original two factors and the two new factors.
It's all done, kid. Make loves class, kid.
What are the solutions of when f of x equals 0? So I'm going to set this equal to 0, and I get x minus 2 equals 0. I get x plus 3 equals 0, so that's x equals 2 and x equals negative 3. And then I get 3x minus 1 equals 0. If I add 1 and divide by 3, I get x is 1/3. And then I get x plus 1 equals 0, and I get x is negative 1. So what are the solutions? Well, I would take each one of these factors. Oops, there it is. I would take each one of these factors and set them equal to 0 and get my 4 answers. Graph it to prove we're correct. Now, just because I like to, I'm going to give my best guess of what I think the graph is going to look like. I think the graph is going to hit the x-axis at 2, negative 3, 1/3, and negative 1. It's even right there. The leading coefficient is positive, so I know it's like some type of U-shaped thing that got a little jiggy here in the middle and something, I don't know. That'd be my best guess. I went ahead on my graphing calculator and I entered it there. I'm going to graph it, and I got that picture that hits at negative 2, 1, negative 1. There's 1/3, and then there's 2 right there. So I was pretty close on the graph. That's not too bad. Last but not least, state intervals for which f of x is greater than 0. F of x is greater than 0 everywhere where you're above the x-axis. So it's greater than 0 from way back here, negative infinity, all the way to that x value of negative 3. And I just have greater than, so I didn't bracketize. If it was or equal to, I'd probably want to bracketize. It's above the x-axis from negative 1 to 1/3. And it's above the x-axis from 2 to infinity. F of x is greater than 0, where's the function above the x-axis? Where f of x is increasing, going down, it's going up from there to there, it's going down, it's going up from there to there. So really what I need is I need to know where these little bumps are, and then I can state those. So I'm gonna go find those bumps, and I'm just gonna be approximate. I'm not even gonna be that exact. I would go put my cursor on that little spot there, and I got about negative 0.3 and about 8.2. Negative 0.3 and 8.2 is one of them, one of those bumps. I'm going to zoom out, and then I'm going to zoom back in on the bottom of that bump if it ever pops up here. So there's my cursor. Where'd my cursor go? Oh, still graphing. Okay, there's my cursor. I'm going to zoom in right there, and hopefully I'll see the bottom of the 2 bumps here. There's one, and again, I'm just getting close. Okay, those are going to be good enough for me. And then I'm going to take my cursor and I'm going to move it over there. So it looks like the bottom of that bump is about, that'd be like an absolute min, negative 2.2, negative 30.9, negative 2.2, negative 30.9. And then this other bump out here, bottom of that guy, so that absolute min right there is about, I don't know, 1.4, negative 20.5. 1.4, negative 20.5. And now what I'm going to be able to do is state these increasing intervals from there to there. So it's increasing from negative 2.2, and these are x values, all the way to negative 0.3. It's also increasing from 1.4 forever to infinity. It's decreasing here and here. It's decreasing over 2 spots. So it's decreasing from negative infinity all the way to that x value of negative 2.2. And it's decreasing from that x value to that x value from negative 0.3 to 1.4. And that's it. Good luck on the quiz. Got nothing else.